Welcome to an extra video for exponent rules for Unit 7 in Math 8. Just wanted to briefly review each of these rules that we have here. When we're talking about the product of powers, we're talking about two or more powers that will be raised to a certain power and multiplied by another power having the same base. If the bases are not the same, you cannot use this rule. What we understand this to mean is that this would end up being 10 to the third power would recognize 10 to the third power times 10 to the fourth power. This becomes inefficient when the exponents get much larger, and so what we want to do with that is we want to make sure that we understand the product rule that's here for product of powers that says when the bases are the same under multiplication, or when you're finding the product of two powers having the same base, you can simply add the exponents. This looks like if we have the base of 2 raised to the m power times 2 raised to the n power. We recognize the bases are the same. I am using multiplication. This rule would end up looking like 2 raised to the m plus n power. When we talk about the quotient of powers, we're talking about division of powers. We would simply see something like this. Let's take our values 10 to the fourth divided by 10 to the third. And we can recognize 10 times 10 times 10 times 10 divided by 10 times 10 times 10. As we can see, we have our numerators all listed out in expanded form, denominators in expanded form. One thing that you have probably seen in the past is when we talk about dividing a number by itself, there may be the term of cancels. I did do air quotes right there because I don't appreciate the term cancels, because cancellation indicates that the value is 0. What I like to remember is that any number divided by itself is equal to 1. So 10 divided by 10 is equal to 1. 10 divided by 10 is equal to 1. 10. You'll see that each of these values are eliminated because of 10 divided by 10. Any number divided by itself is equal to 1. What you recognize is there is remaining a 10 in the numerator and nothing in the denominator except for 1, because 1 is always that greatest common factor of all other values. What that tells us is that my value of 10 to the fourth power divided by 10 to the third power equals 10 to the first power. The rule of quotient of power says when I take any value, such as, I need better room for this one, such as 2 to the m power divided by 2 to the n power, taking the quotient of two powers that have the same base, I can simply take the base and the exponents and find the difference. Please keep in mind that this difference always happens m minus n, or numerator minus denominator, regardless if these values are more or less than the numerator or denominator. If we saw 10 to the third power divided by 10 to the fourth power, we would look to it as 10 to the third power minus the fourth power to be able to make sure that we understand these values. When we talk about power of a power, we recognize that we are taking a power of a number, let's say 4, and we're raising another number. So when we talk about power of a power, we're talking about taking a power of some other power inside. Typically that power will have some other exponent that's given right there. What we need to remember is that this value right here inside of the parentheses becomes the base of this exponent out here. And so we can understand that this is 10 to the fourth power times 10 to the fourth power times 10 to the fourth power times 10 to the fourth power. By the rule of product of powers, we see that we're multiplying several bases with the same base. We could simply add these exponents together. 4 plus 4 plus 4 plus 4 equals 10 to the 16th power. What power of a power does for us is tells us that we can take the power that's given multiplied by the power that's there. So this is kind of like saying 4 groups of 10 to the fourth power, and we simply see that the exponents are multiplied together to give us the same outcome, 10 to the 16th power. The rule for product of powers looks like this. Any value raised to a power that is then again raised to another power will simply be a multiplication of the two exponents. And here again, the bases must be the same for this power to, or for this rule to be used. In the zero power, when we talk about any value that's raised to the zero power, it's really important that we remember that we have that greatest common factor of 1 that is being multiplied by those values. What this 10 to the 0 power means is if you consider something like 10 to the second power, it means that we have 1 being multiplied by 10 2 different times. 10 to the third power obviously would be 1 times 10 times 10 times 10. Understanding this greatest common factor helps us to remember that 10 to the 0 power would mean 1 times 10 0 times. So it would not even be meaningful for us to write times 10 because we are not multiplying anything. The greatest thing we can remember about 0 power is anything raised to the 0 power equals 1. Now, recognizing that piece right there, the way that we recognize that rule, we could say x to the 0 power is equal to 1. When we talk about negative exponent, we need to be considering that negative exponent and thinking about reciprocal. If we take 5 to the negative second power, this negative power in no way changes the base to anything that is negative. It simply tells us that rather than multiplying repeatedly by this base, we're taking the inverse or the reciprocal of this base. What we should first be thinking of is this: 5 to the negative second power should indicate to us that we are thinking of the inverse or the reciprocal of the base being multiplied by the power that's being given. We can simplify this by recognizing 1 raised to the second power is equal to 1, and 5 raised to the second power is equal to 25. And so we see that 5 to the negative second power is equal to 1/25. The negative exponent rule states that for any number raised to a negative exponent, we always think of the reciprocal. To get a reciprocal, you take any number and you are making that number a quotient of 1 and that number. So anytime you want to take a reciprocal, we need to be thinking about taking 1 divided by the number itself in its positive form. The final step, or the final rule that we'll need to know for this assessment, is exponent product rule. The exponent product rule simply states that if I have two numbers, any two numbers that are being multiplied together by a common power, I can recognize the commonality between them similar to the distributive property that says I have two numbers, 5 and 4, which are being multiplied together and both being raised to the same power. It might be helpful to recognize this is 5 times 5 times 4 times 4, and we can regroup these to simply say 5 times 4 times 5 times 4. And we see here the two groupings that are represented there. We simplify these values and recognize that 5 times 4 is 20, and 20 times 20 is here. This gives us a value of 20 being raised to the second power. This rule is expressed with a to the n power times b to the n power is equal to the product of a and b raised to the nth power. There's a quick review of the exponent rules. I hope this is helpful for you. Make sure you reach out if you have extra questions. Have a great day.